Here, I will add the stuff that you missed, though, later, and you can go back and watch the beginning stuff. What was that from? This page? Oh, man, my recording. Can't remember if I hit it. Yeah, okay, so I'm recording. All right, so number 13. I showed you how to solve it. Pretty long break. You may have to go up on the probation list. It's pretty close to 10 minutes. I've already done 2 problems since you've been gone. So, we need to set up an equation. I always tell you, if you're not sure, start with trying to set it up in words. I need 3 numbers that add up to 78. So I need a first number plus a second number. Because again, the reason I'm saying 3 numbers that add up is because it says sum. That's what that means. And then a third number. That's the easiest version I can do right there. That's not an equation yet, but even that might help you if it's a multiple choice test, possibly. Now I could say, well, I'll just make each one of those numbers, because remember, a variable is just an unknown number. I could just say, well, the first number is going to be x, the second number is going to be y, and the third number is going to be z. X plus y plus z equals 78. Problem with that is it doesn't help me solve the problem. I can't solve an equation that has 3 different variables. I just went over that, or wait, no, we're going to go over that next. So I need somehow to create an equation with only 1 variable. And luckily for us, when I have these consecutive numbers, there's a pattern in those numbers, which is going to allow me to just use 1 variable. What's the pattern to go from one number to the next number when numbers are consecutive? What are we doing? Yeah, we're adding 1, right? Every single time. All a consecutive number means is we're adding 1. If I go from 1 to 2, I added 1. From 2 to 3, I added 1. Same way with 17, 18, 19. So here's what we're going to do. We're going to say, well, I do need to have a variable. It is about an unknown number. It's about 3 unknown numbers, but I definitely have to start with something. I always let x be my first number in a problem like this. So x is going to be my first number. What am I doing to get, we said, from the first number to the second number? I'm adding 1, right? So x plus 1, that's my second number. I'm just going to use that symbol. That symbol means number, for those of you not familiar. So all I did is I added 1, and that will give me my second number. Well, what am I going to do to give a third number? I'm going to add 1 again. Now, I don't want to write x plus 1 plus 1. I mean, I could, but I know 1 plus 1 is 2. So I'm just going to write x plus 2. And you could see that here, like 17 plus 2 is 19. 1 plus 2 is 3. So I'm going to write x plus 2 equals my third number. So that's how we would get it down to just 1 variable, but representing 3 different numbers. It's because there was a pattern that we could do that. So now I'm going to use that substitution thing that pops back up. And I'm going to do more on this next time I teach in the class, because it's an important concept that we can use throughout the class. I have $1 in this pocket. I have 4 quarters in this pocket. Does it matter which one I pay with? No, I don't know what for. 10 people. Doesn't matter, right? I can take $1 and I can substitute that out and put 4 quarters back up on the counter. I can take that out, put the 4 quarters up. Or I can pull the 4 quarters back, put the $1 up. They are the same exact thing. The equal sign tells us they are the same thing. $1 equals 4 quarters. If 2 things equal each other, it does not matter which one you use. They're the same. They're equal. Doesn't matter which one I use. All right.
Is that number 10?
No, number 13. If you're talking about what I'm doing.
Oh.
So, if I know that an equal sign tells me I can use anything I want, well, I've got some equal signs right here. I know that my first number is equal to x, so I could use x instead of my first number. I know that my second number is equal to x plus 1, so I could use x plus 1 instead of second number. And then again, this is an addition problem, so that's why I have the other pluses. I know my third number is equal to x plus 2, so I could use either one, so now I want to use x plus 2 instead of third number. And then 78 stays the same, that doesn't change. So that's my equation. That's how you would create the equation in this problem. Now, you're not done. You'd want to do the math, and you want to say, okay, well, let's make this a shorter problem. Let's combine like terms. Because if I have 3 x's, how many x's do I have? I just told you. 3 of them, right? So x plus x plus x. Can I scroll up a little bit, maybe? Oh, that's fine. That'll work. So x plus x plus x. I'm going to do a different color to make it a little easier. X plus x plus x is just 3x. And then 1 plus 2 is just 3. And then equals 78 doesn't change. So that's the final answer you probably see on the midterm. So you're going to see probably one word problem like that on there. That's one of the word problems you'll have to create an equation for. There'll be a few of them you have to do that on. Won't be, I don't even think I'm going to have to make you solve those. You're just going to create the equation. And then I might give you some word problems where you just solve. You don't have to create the equation. Be a little bit of both. All right, so now look at sheet 1-3. This is just solving more complex equations. I'm just going to do one of these. I've got a bunch of videos on my YouTube about solving equations. If you don't remember how to do it, frankly, I shouldn't even do any of them. You guys should just go out and do that. Oh. So let's choose. I think this is probably a pretty good example of one that I would put on the quiz. Something like that. And again, quiz is not open note, so you're going to need to know how to solve these on your own. So the first thing I need to do is the distributive property. I cannot combine y subtract 1. They're two totally separate things. Y is a variable. We don't know, it's a missing number. We don't know what number it is. If I don't know what number it is, how can I possibly subtract 1 from it and get an answer? Like I don't know what number it is to subtract 1 from. So we can't combine a variable and a number. But we did learn, thanks to the distributive property, that I can take -3 and multiply it times y, and then take -3 and multiply it times -1. So that's what we're going to do. So we're going to write this left side, we're not going to do anything to yet. So we're going to say -3y plus 3, and then subtract 1. So the -3y is just -3 times y. And then -3 times -1 gives me +3. Negative times negative is positive. So now my next step. Just ignore that there's a problem there. We're going to work around it. So now I can combine some like terms, because the parentheses are gone. So my next step is I ignore one side and I just look at the left side. And I try to combine like terms. If I have them, well, I do have them. This is a y term and that's a y term. So I can combine this. I can't do anything with the subtract 7, because that's just a number, but I can combine these like terms. So that gives me 6y subtract 7 equals, now on this side I can combine like terms that are numbers. I don't have I don't have multiple terms that have y in them, but I do have numbers that I can combine. So the negative 3y plus 2 is what I would have on that side. So on the left, I combine the y's. On the right, I combine the numbers. I don't, if you'll notice, I haven't subtracted anything below yet. Like I didn't try to say subtract 2y and then subtract 2y. I didn't do that, which is what a lot of people try to do early in the problem. Don't immediately think about doing that. First, try to combine terms. Oh boy, I messed that all up. I forgot I'm not in my smartboard, so I can't just go backwards. So I'll rewrite it over here. There. So now I'm down to this stage. Now, when you are at the stage where you can't combine anything, that's when you do the subtract below or add below the equation to get rid of stuff. So I want to get rid of all of the variables on the right. Once I've combined them all, once I've combined all the like terms, I want to get rid of all the variables on the right. Well, the only variables now are just the 3y. And to get rid of them, I need to do the opposite. So they will cancel out. But if I do it on one side, I've got to do it on the other side. So that gives me 9y, subtract 7, equals 2. Now we just have a two-step equation, which is what we skipped over in the other worksheet a minute ago. So I'm going to go ahead and just solve out a two-step equation. We always start with the term that does not have the variable. I'm sorry. We start with the term that doesn't have the variable we're solving for. So here we're solving for y. So the term that doesn't have the y in it is the 7. So I want to start with that. So that would give me plus 7 on both sides. That goes away. And I get 9y equals 9. My last step is to divide by 9. So I get y equals 1. So that's an example of a pretty complex equation that you would have to solve. Now, my feeling is I'll probably put some multiple choice questions on there, and this would be an example of a good multiple choice. I'll give you a more complex equation, but I'll give you possible answers, so that way when you solve it out, you'll know whether or not hopefully you made a mistake, unless you happen to make a mistake and one of the answers is still on there. Any questions on anything I did to solve that out? So in addition to this review, there's obviously tons of videos on my YouTube that you can watch about solving equations also. There are some word problems on this page, but I'm not going to go over those. We'll go over some of the future word problems that are pretty much the same thing. So next, literal equations. We did this a long time ago. Again, I don't know why this one is so hard, because the math behind it's not hard. It's just the concept confuses you guys. So most of you are sleeping. I cannot solve and come up with a number for an answer if I have two variables and only one equation. It is not possible. So I think the first thing that throws you guys off is when it says solve, you think solving means coming up with a number. Sometimes it does. Sometimes it doesn't. This is one of those times when it doesn't. You're not going to come up with a number when it says solve. Solve just means get the variable by itself. That just means get the variable by itself. Now, if that happens to mean that we wind up getting a number, great. If it doesn't, then we just leave whatever we have, even if it's got other variables in it, which is what's going to happen here. So if I want to solve for m, That just means I get m all by itself. I get rid of everything else that's on the same side where the m. So again, to do that, I start with the term that doesn't have the m. Now in the other problems, the term that doesn't have the variable is normally a number. It's not in this problem. Here, the term that doesn't have the variable happens to be a term with a different variable. That's fine. We can still get rid of that. If you have 3 needles in your hand, I can still get rid of the 3 needles by subtracting them out. I just subtract them from you. Just take them away. If you were in debt 3 needles, then I'd give you 3 needles, and that would cancel out. That doesn't make sense. If I do it on one side, though, I've got to do it on the other side. So now, again, my goal is to get m all by itself. Well, I've pretty much achieved that goal. M is all by itself now, so I'm kind of done with that side. Here's the next thing, though. This is where kids, because they think they're supposed to come up with an answer, like a number for the answer, just because it said solve, you still can't combine a term with a number and a term with a variable. I still can't combine those to make it one number, one thing. It's just 7 subtract 3m. That's the final answer. If you have more than one variable and only one equation, and they're asking you to solve for something, unless they tell you that n equals something, like if they would have said, and n equals 2, well, then you could solve it because now you got rid of a variable. You're going to put that number 2 into the equation. But if you have 2 variables, or more than 2 variables, and only one equation, your final answer is going to have a bunch of variables in it. Even if it says solve. Solve just means get the variable by itself. So we'll do one more real quick. I'm going to do 6. And I'm going to just go through it pretty quickly. This will be recorded, though. It is recorded. I'll post it after school. I want to solve for m. That means I got to get m all by itself. Well, I start with the term that doesn't have the m. I always start with the other terms. In this case, it has a variable in it, but that doesn't matter. I still want to start with that other term. I need to subtract it to completely get rid of that. Because 4n, again, 4 needles. And if I subtract 4 needles away, then that means I have 0 needles. I'm just saying needles because it starts with an N. But if I subtract it on that side, I have to subtract it on that side. So -2 subtract 4n. Well, that leaves me with -6m on this side. Again, I can't do anything with -2 subtract 4n. One's got a variable, one doesn't. All I can do is just rewrite it. I'm going to have to write it kind of small. So it just becomes -2 subtract 4n. That's all I can do. Remember, multiple variables, but only one equation, you're going to have variables left over. Like there's nothing you're going to be able to do. Now, my last step, I divide by -6. Make sure you include the negative. I feel like oh no, I'm doing a different problem. And then over here, I divide by -6 as well. So I get, I'm gonna give myself a little more room here because you're going to need to see this. So I get m equals -2 subtract 4n divided by -6. That will not be your final answer on the quiz, on midterm. I kind of let you slide with not simplifying things during the year, but that won't happen on the midterm. Now, again, pretty good chance this will be another multiple choice type question. So if you can figure out the next step, even if you don't know exactly what you would do on your own, you'll be fine. I need to find out, can I simplify that? Is there a number that will go into all of those numbers? Like, just like you would simplify 2/4 into 1/2. Same concept. Well, 2, technically -2, because I don't want to leave a negative on the bottom. -2 will go into all of those numbers. -2 will go into -2. Negative 2 will go into negative 4, and negative 2 will go into negative 6. So that's what I would divide every single number by. I'd divide each of those by, oh no.
If you put it in fraction form, like 2 over 6 and 4 over 6, then it goes to 1/3 and 1/2. No.
Well, it'd go to 1/3 and 2/3.
Yeah.
But I'm not going to break it out into two separate fractions. And I can't scroll down. All right, I'm just going to have to come over here. I forgot I'm not in Smart Notebook. I keep forgetting that. If I divided each of those by negative 2, I get that. So again, negative 2 divided by negative 2 is just 1. Negative 4n divided by negative 2, because a negative divided by a negative is a positive. That gives me positive 2n, because I don't get rid of the n when I divide by negative 2. And then negative 6 divided by negative 2 gives me the 3. So you can just kind of, again, pretty good chance this would be a multiple choice. If you can kind of figure out which answer matches up, like I might give you versions of this, like 2 plus n over 3 or something like that. If you can figure out that that's not the right answer, then you'll be fine. And I'll give you a few other versions. And then there's no real word problems on literal equations, so we don't have to worry about word problems there. All right, so now compound inequalities. I'm sorry, actually just inequalities first. We're going to solve these out on the next one. I just want to show you how to graph on this, because you will have to, again, some will be multiple choice, some you'll have to solve. If you solve this out, all you're doing is just like solving an equation. So just because it's got the inequality sign doesn't mean it's any different than solving an equation. We talked about that before. So if I take this and I say, all right, well, I want to, and again, I can't do anything on the left side. I can't do anything on the right side. There's no like terms to combine. I need to get I need to get rid of the variables on the right and get them onto the left. Well, I do the same thing I would in I guess I kind of am solving this out again. So I'd add 2t to both sides. That's not plus 2 plus. That's 2t and 2t. Well, that would give me negative 4t over here. Subtract 3. That goes away. I just have negative 19. Oh, but boy, it's not equal. It's less than. So that left side is less than the right side. So my next step, again, just like solving an equation with an equal sign, I need to get rid of, so I focus on the side where the variable is. I need to get rid of that number. Ignore that. So I would say, all right, well, to get rid of that number, I have to add it, plus 3. So if you can't see that, I just added 3 to the left, which means I need to add 3 to the right. Well, that gives me negative 16 over here is less than negative 4t. So again, the steps are the exact same until your last step. This is the only thing that's different, the only thing you have to remember when you solve these out. If we divide, so our last step is always division, right? We say that over and over again. If we divide by a negative number on our last step, when we have an inequality, you've got to remember this one little thing. So those cancel out, and I still have the variable t. You have got to flip the sign. So I did have a less than sign. Now I flipped it and I have a greater than sign.
And they have to graph it.
Well, we're going to get to that later. So you have to remember, if you divide by negative on your last step, then you have to flip the sign. Now, it doesn't matter if the top number is negative. Like this was negative 16. That doesn't matter. We don't care what the top number is. All that matters is what the bottom number is. So if that would have been a positive 4, we wouldn't have flipped it. But if you divide by negative, you got to flip it. So then you will have to graph it, and you'll also have to just pick a graph. So if we graph that, so it says t is greater than 4. So the graphing is where we said, okay, we need to put an open or a closed circle on the number itself. So in this case, it's 4. This is only a less than sign. It's not less than or equal to. So if it's just a less than sign, then we leave it as an open circle. That tells us 4 is not actually an answer. Now we say, okay, we want all the numbers greater than 4. Well, clearly 0, 1, 2, 3 are not greater than 4, right? Because t has to be greater than 4. So our answers are all the numbers that are greater than 4, which goes this way.
Right.
So then we shade it in. Remember, the shading was the last part. Now, if there would have been an equal sign underneath the little less than, then we would have colored in this circle also, because the equal sign would be saying that 4 is also a solution, but there wasn't one. So you'll have a few problems on how to do inequalities. You will have some problems on compound inequalities. I'm just going to get rid of that. You will have problems on compound inequalities, and you might even have to set up an equation. Remember how we did the equation about either I baked fish or I cooked fish, they're baking a cake, and it said, you know, if you have something that has to be greater than a certain number but less than a certain number, then that made it in between those two numbers. If it's all real numbers that are less than -3 or greater than or equal to 5, we would say, okay, well, x would have to be less than -3, or x would have to be greater than or equal to 5. So that's the way you would write that. X is less than, I mean, literally, you're just putting what they say in words and using the symbols. X would stand for the all real numbers that are less than those. So.
What do you do with the -2? What do you do with the -2 in the middle?
Oh, this one down here? I guess I was going to show this one to them, but
Oh, that's one.
were you worried about the negative part, or?
No, aren't you supposed to
Yeah, you create two equations.
add 2 to both sides?
So if you'll notice in some of these problems on this worksheet, oh, that's cool, I didn't know I could do that. Not on the internet, at least. Oh, I didn't mean to do it over there. Let's just go down a little bit. So what Ms. Holtz is asking about is, how do you do these types of problems where it's all jammed together? You notice here we have 2 equations, I'm sorry, 2 inequalities. There's an inequality, and then here's an inequality. Same way here. 2 separate problems. And all the other ones, though, we don't. But technically you do. They've just smushed them all together into one problem. Technically, this is saying y plus 2 is less than -4, but greater than -10. This is pretty easy to see. Y plus 2 is greater than -10 because the symbol's already set up for you. It's a little tougher to understand that that's actually saying y plus 2 is less than -4. You never start with the -4. You don't say -4 is greater than y plus 2. You always start with the part of the equation that has the variable in it. So this is y plus 2 is greater than negative 10. And y is less than, oh, y plus 2 should be. So you have y plus 2 is less than negative 4 is the way you could write that or would write that. If you wanted to put the y plus 2 on the other side. And then there's a second equation, y plus 2 is greater than negative 10. So there's actually two equations in that one equation. You would just now solve both of those. Make sure you include this whole thing. Too many people were saying, oh, well, this is, actually, I don't even know what they were doing, to tell you the truth. They were saying, well, that's y plus 4, and then 2 is greater than negative 10. That's not how you break that up. You don't split the y into 2. You take the whole thing that's in the middle and you use it twice, basically. You use it once here, and then once again here.
And then you get rid of 2.
And now now you just solve it like you would solve any equations. So you would say, all right, well, let me just solve. So y plus 2 is less than 4. I would subtract 2, and I would just have y is less than negative 6. And then I would just solve this, subtract 2, and then y would be greater than negative 12. So y has to be less than negative 6, and it has to be greater than negative 12.
Did you write it down?
So when you graph this, it's one of those situations. Remember we said if this is in the middle, then when you graph it, your answer is going to be, or your shaded region is going to be in the middle. So we'll start with negative 13. So negative 13, negative 12, negative 11, negative 10, negative 9, negative 8, 7, negative 6, negative 5. So you graph it the same way, you put circles. Now in this case, was there, yeah, there's still no equal sign beneath either of those. So we still put an open circle on both of those numbers. Open circle on negative 6, open circle on negative 12. And then we say, okay, well, if y, this is the shortcut version, if y is in the middle, the variable is in the middle of the two numbers, then our shaded region is in the middle of the two numbers. Or you can think about the better way, if you understood it, would be, well, I need all my answers to be greater than, less than negative 6. Well, if this is negative 6, numbers to the left are less than. So they need to be less than that number. But they also have to be greater than 12. Well, that's the numbers going this way. So the only numbers that are both of those, less than negative 6 and greater than negative 12, that's the only numbers, the numbers that are in between, that fit both of those two down. Now, if it happens to be an OR problem like these, then you just graph each of those separately on the same graph, because we don't care which one it is. It could be either of them. And is the one that's a little tricky. And you could have no solution with an and problem. That's possible. We went over some of those a long time ago. Well, unfortunately, we can't go over everything. About 30 minutes. All right, so next worksheet, we're on graphing. Man, oh man, was I a little disappointed on the tests in the graphing. A lot of us are still struggling to graph. And we did this a lot. So there's my y-axis. There's my x-axis. So here's a quick version again. Tons of videos on this on the site. If you don't know how to get to, I don't know if I mentioned this at my class, but if you don't know how to get to the site I keep mentioning, just come see me at lunch or something. Or for you guys, you can just stay after, since we're going to lunch next. I start with the y-intercept. The y-intercept is the part that's just a number. There's no variable with it. There's no x with it. So that's my y-intercept. I just put a point on that y-intercept. That's my starting point, my first point. I need 2 points to graph a line. So that's my first point. Now I need to find my second point. Well, my second point comes from the slope. That's whatever number is in front of the x. If we don't see a number, then the number is 1. X does not equal 1. I might smack the next kid that says that to me. There is a 1 in front of the variable x, because we have 1x. Like literally, how many x's do you see in this problem? 1. Well, that's because we have 1x there. But x doesn't equal 1. No, I mean, I guess you could solve it out and maybe it might happen to equal 1, but that 1 in front of the x does not mean that x equals 1. It means there's 1x, one of them. So, this is my slope. Or it's my rise over run, we learned is the equation. You need to convert that to a fraction. The way we convert a whole number into a fraction is we just put it over 1. Anything. 0 over 1 works. So 1 over 1, 2 over 1, whatever the number is, over 1. Now I have my rise and my run number. A positive 1, and it's a run, a positive run of 1 means I go right 1. Positive means go to the right, and then obviously the number is 1. A positive rise number means I go up 1. Because going up is a positive rise direction. So I need to go over 1 and up 1, which puts me right there. I'm sorry, I need to go right 1 and then up 1. Shouldn't have said over. So that's how my line would look. Now I could continue that pattern if I wanted. I could keep going right 1 over 1, right 1 over 1, right 1 over 1. And if you'll notice, then they would all line up, and it makes it pretty easy to draw the line. But that's how we graphed. I'll do one more real quick. If they almost go off the graph, which you won't have to worry about with my test. We talked about how you fix that. I'm not going to worry about it right now because I'm creating a test, so you won't have to worry about that. So positive 1, that's my starting point. That's where I start. That's where I put my first point, right there. I now need to figure out, how do I get to the next point? Well, again, I take the slope. In this case, it's a negative number. Doesn't matter though. I still make that rise over run. So I'm not doing this problem. Oh, I do need to do that problem next time. So I say, okay, well, my rise number is going to be the -5, but I need to put that over 1. So a run of 1 means I go right 1 again, and a rise of -5. Now that means I go down though, because it's a negative number. So a negative rise means I have to go down. So I go over 1 and then down 5. So there is my second point, and my line would just be the line that connected those.
No, that's 2. Yeah.
So let me do this last one. I should have done this one instead. I mean, I've pretty much done all of these, but if you're going to study, just write the equation and ignore the line that I created and try to do it on your own, and then you have the answer if you're writing all this down. I'm going to have to create this graph with the, actually, I guess I don't have to. Yeah, I will create it with the x-axis a little higher though, so I don't go off the graph. Right, so that's the y-axis and the x-axis. So again, my y-intercept is the number that's all by itself. -5. 1, 2, 3, 4, 5. There's -5. Now in this case, my rise and my run number is already a fraction. So I don't need to do that whole over 1 thing. It's already a fraction. I already have a rise number and a run number. They are both positive. So again, positive rise means I go up 2. Positive run means I go right 3. So right 3, 1, 2, 3, up 2, 1, 2. That will be my second point. And then just draw your line through the 2 points. There are other ways to graph this, like you can just plug in numbers. We talked about that before. If you really, really wanted to, you could just say, well, I'm just going to plug a number in and try to come up with a point on the graph. So you could plug in 1 for x, solve out for y, and you would get 1 comma negative 5. I'm sorry, no, you wouldn't. 1 comma negative 4, which is the point we already put on there. You could plug in 0 for x, and you get positive 1, which we also already have on there. This one would be easier to plug in numbers for. You could pick an x and a y that work pretty easily on that one. So if for some reason you get one, you don't remember this rise over run stuff, you could try to plug in numbers. If it's not a real complex equation, that'll work. Here are the word problems, though. You do need to know how to set up word problems. Might be the last thing we get to, but you definitely need to see a couple of word problems. I didn't really cover this 7, 8, 9. But you do need to know how, you will need to know how to create an equation from a graph. So if I give you the graph instead of the equation, so like let's talk about this one right here. So what they're saying in 7, 8, 9, you will have something like this. Here's how I'm going to tell you to do it, since we did it a little differently than just using a formula. Although you know the formula now because we did it last time. We need a graph. We need to take a graph of this and then create the equation from the graph. Just draw a quick graph. I think I am going to go to the smart. So -1, 3, -3, 1. Remember that. There, right here. So negative. So here were the 2 points they gave you. -1, 3 and -3, 1, right? That's what I said. They want to know what is the equation for the line. Gosh darn it. What's the equation for the line that goes through those 2 points? Well, we haven't done anything exactly like that. What I told you to do, again, here's your process when you see one like this on the test. If I just give you 2 points and I say graph the line that goes through those 2 points, well, I'm sorry, don't graph it. Create the equation of the line that goes through those 2 points. We've done this from a graph before. We've never done it just from the 2 points. I mean, we sort of have, but what we did is we said, well, let's just create the graph. Let's just put those 2 points on a graph. So -1 and 3 is right there. And then -3 and 1 is right there. Then we created the line. So then we drew the line. Now from the line, you should be able to create the graph. I'm sorry, the equation. The way we did that, oh boy, and this isn't always perfect. Huh. Forgot about that. It'll work in this one. It won't work in every one. I'll probably just give you one where it'll work. We need to find the y-intercept. The y-intercept is where it goes through the y-axis. So that's this number right here. It goes through the y-axis at +4. So our equation, because remember, this is that's our equation.
What number is
It's number, I think it's number, I don't know.
that?
It's, I want to say it's 7, but I don't remember the number. It was sheet 2-1, I think, and then the first problem with just 2 ordered pairs. It was the first thing on linear functions. 2, 1 should be linear functions. Or I'm sorry, linear equation. I'll find it in a second, but regardless, he just needs to know how to do this problem. So he just copies this down. He can try the other ones on the packet. So I know that the y-intercept is where my line crosses the y-axis. Well, where does my line cross the y-axis? Well, it crosses right here. It's a 4. So I would say that's going to be my end part of my equation is +4. If it's multiple choice, you might be able to figure it out just by getting that alone, or at least eliminate a couple of answers.
Yeah.
Now, though, and then you're going to have a y in here, and you're going to have an x in here. We know that. I just need to figure out what is my slope. Well, slope is the rise over the run. So I need to figure out how far do I run, and then how far do I rise to get from one point to another point, just like when we draw the graph. When we draw the graph, we count left or right for the run, and then up or down. Well, here we're doing the same thing. We're counting left or right, and up or down, and we get 2s. But now we have to figure out what slope that is. So my rise over my run is 2 over 2. Please use your calculators on that, because I get all kind of answers on that. People say 2, people say 0. 2 divided by 2 is 1. Any number divided by itself is 1. So you could write in 1. Now remember, if on the quiz, this is not an answer, this is not an option, which it probably wouldn't be written like that, they would write it like this. They're the same thing. Just remember that if there's a 1 in front of the x, they might get rid of the 1, or I should say I might get rid of the 1. And I might just show you y equals x plus 4. Same thing though, because you could write the 1 in there and then you'd have the same thing. We just don't normally show that 1 in front of a variable. We show every other number in front of it, but we don't show the 1. Fractions, decimals, just not the 1. So you need to know how to create a line from an equation and how to create an equation from a line, or just even from 2 points. There's a much longer, more difficult way to create it from 2 points that we never even did, just because in my past experience, it's very challenging to get the final part of the equation. The slope's not that bad, but I think visually, now let's say for some reason, and this won't happen on mine, but you might see it on a future test. If when you're creating the line and it goes like this, well, shoot, I accidentally drew it. Oh, I know what I meant to do. So let's say the line looks like that, and you're trying to figure out how to do it. You're not going to be able to know what the y-intercept is. Like in mine, it went right through 4, so I knew the last part was 4. This is the disadvantage to trying to draw the line from the 2 points they give you. Like let's say the 2 points they gave you were this point and then this point. If they gave you those 2 points and you try to create the line on a graph and then do the equation, you're going to have to guess at what that number is, what that y-intercept is. If you're creating the equation without multiple choice answers, then you're probably going to be out of luck. You'll go back through this next year and they'll go through the other way to do it. So they'll show you how to solve for the b value where you get an actual value. It's pretty complex though, so I've just chosen to not do that. And you won't see it on my midterm. I'm just telling you next year, they'll do something new that you haven't seen. I mean, you won't remember a lot of it anyway after summer, but when they go through it, there is a way to do it. We just didn't go over it in this class. All right, we still got 15 minutes. And I know this is boring, but again, I'm recording it, so I'm trying to get as much done as possible, even though you're probably falling asleep. You need to take a brain break, that's fine. Just remember it's recorded if you want to go back and look at it. I'll repeat the first part that I did that I forgot to record so that you can see the first worksheet or two. Oh, so now back to these. Oh, so you will need to know how to do these word problems. Oops. So these are the types of word problems you will have to know. Actually, let's go to the next sheet. What was that? Huh, did I skip a worksheet? 2? Oh, no, I'm sorry. We skipped 2-2. There was no 2-2. All right, so here's the next type of graphing. We just did this. Actually, no, you guys didn't just do this. You missed the graphing day we did. So this is kind of your makeup day from that. Here's the next type of graph you need to understand how to do. I will give you the graphs. You will not have to create these X and Y axes things. All right. So now Y is not by itself. You cannot graph this by doing the whole y-intercept thing. There's not a, well, there is a y-intercept, but we don't know it from the equation. There's not a slope. Well, I'm sorry, there is a slope, but we don't know it from the equation. You could, if you really like that if you like that literal equation stuff, you could actually change these, and you could say, well, I want to get y all by itself, so that I can graph it like that, y equals mx plus b. And I could say, okay, well, if I want to get y all by itself, I just need to add 5x to this side, which means I need to add 5x to this side. So that would give me y equals 5x subtract 10. Now it's in the form of y equals mx plus b. You could graph that. That you could do. Now the problem is with that, if you'll notice, the y-intercept is way off the graph with this -10. And that's how they keep you from just changing the equation into a new equation and graphing it. They make sure that it doesn't work, like that it goes way off the graph. But you could do that. That equation would work. Here's how you do it, though, without doing that. This is where you do that cover up and solve thing that we did. We say, okay, we're going to get rid of, or not get rid of, but we're going to ignore one term. I mean, that's just ridiculous. That's the dumbest thing. I mean, no matter how I draw the graph, it's going to be off the graph. Like, there's nothing I can do with that graph they gave us.
Count by twos? Counting minus 2, 4?
Well, yeah, but I mean, to give that to them and make them come up with all of that, yeah. I mean, could I do it? I could do it, yeah. But to give them that and make them, I mean, we're already learning the math itself. I've learned the math. I know the math, but they're making them worry about how to create a graph and how to do the math. And I hate this book. I really hate it. Anyway, so what Ms. Holtz is saying is, as you can see, y equals -10. We said cover up 1 and solve, and whatever you get, that you just put a point on that number where y equals -10. Well, that's way off the graph, obviously. -10, if we went by ones, if we counted by ones, would be way off the graph down here. So what Ms. Holtz is saying, and I'm going to erase this in a second. Oh, boy, I can't erase in this as easily. She's just saying make every jump worth 2 instead of just 1, so that we can make this -10 down here. So this would be -2, -4, -6, -8, and then this would be -10. But that's I mean, you'll have much easier. You'll already have the graph you need online. So now, the next thing we would do, now we would cover up the y, and we would solve for x. So when we solve for x, we just wind up dividing by whatever number is there. That's the thing about these equations, by the way. You always just wind up dividing by whatever number is there. They're always very simple, straightforward, just because that's what standard form is. Every equation will always be in that form because that's the definition of standard form. You'll have a term with an x, a term with a y, and then a number every time. So you always wind up just dividing by whatever the number is with the variable. So this you'll divide by -3. This you'll divide by -6. This you'll divide by 4. This you'll divide by -12. It will always work like that. So now we divide by -5, which means we divide by -5 here. So I get x equals 2. Well, that one I can put right. Oh, no, can't do that. Because I forgot I'm going by 2's.
Oh, yeah.
Yeah, see, that's why that's a pain in the butt. So remember, I had to count by 2's. So counting by 2's, x equals 2 is right here, actually. So my line would look like that. Here, let's do another one that comes out a little better. I'm going to do a second one. We'll do this one. Shoot, even that one doesn't come out great. We'll do this one right here. So again, I'm going to cover up one term, solve for the other term. I always divide by whatever the number is with it. So divide by 6, divide by -6. I get y equals -2. So this one will work out a little better. So there's my y. There's my x. So y equals -2 is right there. So now I'm going to come back up here. Man, isn't working. Oh, there we go. So now I already solved for y. So now I'm going to cover up the y. I divide by -3. Again, whatever the number is with the variable, that's the number you're going to divide by. Divide by -3, and I get x equals -4. So an x of -4 is right here. And then that's the way you solve it. So that's the way we did standard form. We covered up one and we solved for the other. Or what we really did, I'm doing the shortcut, we said, let's plug in 0 for x and solve for y, which would have given us -2. Let's plug in 0 for y and solve for x, which would give us the -4. This is the same thing. It's all the same thing. I'm just showing you the shortcut version instead of the, not that it's any longer, it's the same exact thing. But. Now you will have some word problems you need to do. I think these word problems are super easy though. All you have to do when you have word problems is you just match up the variable with the number that is about that variable. So here, we know x is about field goals, right? It tells us that right there. How much is a field goal worth? Somebody's got to know how much field goal is worth. How much is a field goal worth in football?
I don't know. And like football.
Nobody knows how much a field goal is?
3.
3, right? I mean, it tells you that in the problem. It says a field goal is worth 3 points, so it does tell you that if you didn't know. They would never just expect you to know that. Joe, phone up. So, all you need to do in this type of problem is match up what the variable is about. So the variable is about field goals. Which number is about field goals? Well, 3 is about field goals. So then 3 goes with the x. All right, well then, what is y about? Y is about touchdowns. Y is about the number of touchdowns. All right. Well, which number goes with Y? I'm sorry. Y is about touchdowns, not the number of touchdowns, but it's about touchdowns. So which number is about touchdowns? Well, touchdowns are 7 points. So I just take that number and put it with Y. And then the big number is typically the ending number. So these word problems I don't think are that bad. I really needed to do, why didn't I do word problems? Did they not have word problems on this sheet? Oh, they did. They had a tougher word problem than that. I don't love that word problem, so we'll come back to a different one either. We're not going to get to it today. I do want to do one more thing though, real quick.
Wait, Mr. Gill,
Mm-hmm.
do you have the schedule for tomorrow?
For the exam?
Yeah.
Tomorrow you go to third period first. So just go to your third period class first tomorrow. And then your first period is at the end of the day, which is your exam. So which one of these am I going to do? Why is it? Oh, these are some weird ones. I do want to go over the. I'm not going to put that on. I keep forgetting I'm making the test up, and that I don't have anything like that going on. No, it's not going to be 10 questions. It'll be a lot longer than that. A lot of it will be multiple choice. All right, so real quick, let's do functions. Probably do this over again tomorrow also. Domain and range. This should be easy points. Especially if some of them are multiple choice, which some of them will be. Your domain. Here are the rules.
Easy, yeah.
Domain. X values. Smallest to largest. And then lastly, let's make it a little bit so we can see it. Don't repeat any numbers. So I would suggest that I'm doing all of these for you. I'd suggest if you actually care about your midterm grade and your semester grade, go back and try to do these, like cover up the answer that you've written down that I did and try to do it on your own. So X value, oh, and then range. Range is kind of the same thing, only the range is the Y values. Yeah, your output numbers. X's are inputs, Y is output. So it's the Y values, that's a Y. And again, same thing, smallest to largest. And don't repeat. Same exact things for the second and third thing. Those are the rules when you create it. There's no math involved. I mean, nothing, no calculations involved. So I'm going to do domain first. Okay, so it's the X values. So I'm pulling from X values. Smallest to largest, where they're already in order from smallest to largest. So that makes it easy. So 3, 5, 7, 8, 11. That's my domain. None of them were repeated, so I didn't even have to worry about repeating any of them. So that was my domain. So my range. Now I do the Y values. Smallest to largest. Well, they're already in order, smallest to largest. So 6, 7. Now here's the only thing I need to make sure of. I don't repeat any numbers. I'm not going to write the 7 again. It's the only thing I got to worry about in this. 9 and then 14. So that's my range. Again, those are your rules right there. Not open note those, so you're going to have to remember what that means for about 3 days. 3.5.
Wait, when are we going to test it?
Testing here is your last exam for the week. So Friday at the end of the day. I know you're gonna be pretty fried by then, I would imagine. We're gonna go ahead and stop right there since we're done, since we have no more time left. We'll do a little bit more on the other 2 or 3 worksheets right before the exam on Friday. I'll post this review. I'll add the little piece that I missed. I doubt I record any other classes. I mean, it's all going to be the same worksheets, all those same worksheets. So, yeah, you will get a calculator. Oh no, don't put it. Well, that's fine. I can have one. Did you just throw yours in here?
Yeah, it's still here, yeah.
That one right here. All right, good luck tomorrow. First period exam. But go to third period first. That's confusing. Wow, that was nobody here today. All right, anybody still on? Nope. Let's stop the recording.